Welcome to all. So today we are going to see a concept called as forest plot. So now most of the time we come across certain questions like whether can this intervention be made or not, right? For example, can a steroid be given for this particular condition or not? So this is the question. One study will say yes, you can proceed and go ahead and giving steroids. But similarly, there could be other studies which can say that no, the steroid is contraindicated in that particular situation. Some other studies like a study 3 or study 4, the other studies can say you can give steroids but only to a particular population. The other study can say you can give steroids but there are limited harm in that also. So this kind of varied results can be seen when you analyze a lot of studies asking the same question, right? So in that case, to represent this collective data, what you need to do, okay? So this is the question which is put forward, okay? So the same question you're going to handle by 4 or 5 different studies and you're going to express all the study data in one single shot, okay? So forest plot is meant for that. For example, say one study says that your intervention is favorable. The second study also says the intervention is favorable. The third study says the intervention is favorable but not statistically important. The fourth study can say that it can be harmful or significant sort of things, right? So just how to represent everything in single shot. This is called as forest plot, okay? So when we come across meta-analysis of multiple studies, you will see a figure similar to what you see here in the picture, right? So you need to understand how to interpret this particular figure, okay? So we'll go inside the forest plot. So this is the forest plot given to you. Hope it is easy, right? So what exactly means the horizontal line? What is the vertical line? What are these boxes? What is this arrow? Why there is a diamond and how to interpret this? This is what we are going to see. So here they have 1, 2, 3, 4, 5, 6, 7, 8, totally 8 studies, okay? So we are going to represent all the 8 studies in one single picture, okay? So we are going to represent all the 8 studies in one single picture. That is the forest plot. So first, when you see a forest plot, you will see something like a straight line, the straight vertical line. What you see here is a straight vertical line, right? So this straight vertical line means a line of null effect, okay? So this divides your column into the right and the left, right? So here one side will be marked as whether it's favorable or not, the other side is not, okay? So for example, not favorable is this side and this side could be favorable. That is, your intervention is going to be favorable, that is beneficial effect, and this is not favorable. So this central line is a line of null effect, that is at that point there is either harm there nor there is benefit, okay? So this is called as the null line or line of null effect. So this central line is the first step as forest plot is. So the vertical line is called as the line of null effect. This line is placed at the value where there is no association between exposure and outcome or no difference between the two interventions under study. You need to understand that relative statics like the OR or the RR have a null effect value of 1, the central value of 1. But the absolute statics like AR or ARR or SMD has a null difference of 0, that is this point, okay? In certain groups you will be putting as 1.0, in certain groups it will be paid as 0.0, okay? So now we have drawn a central line, the line of null effect we have drawn, and we have drawn the horizontal line. The horizontal line we are marking as there is favors treatment and favors control, favors treatment or favors control, either way it can be. So next step is we are going to draw certain horizontal lines. For example, if I draw a line like this and a box like this, you will be seeing a line like this and a box like this. Sometimes you will see a line like this and a small box like this, right? So these represent individual studies, okay? So the box represents the number of participants, okay? When the box is big, it means that there is a lot of number of participants. When the box is very small, it means that there is limited number of participants in that particular study, okay? So the horizontal line represents the confidence interval, that is 95% of confidence interval. That can be associated only with this small line itself, that is within a small window, you will be able to accommodate your 95% confidence interval, the number of population. When the box size increases, this horizontal line, there is a confidence interval line decreases, okay? Similarly, when the box size is very small, the confidence interval line also extends. Okay, so this is the next step you need to learn. So first we have drawn a null line, then we have drawn a horizontal line. The null line is the point where there is neither benefit nor a difference. So after this, we are going to represent each and every study. For example, my study population, the first study population had 100 people. So I draw a small box, and the confidence interval is with 95% confidence interval, I get a horizontal line. The next study has a total number of participants as 500. So the box is going to be pretty large, right? Compared to 100, 500 box should be pretty large. So when I draw a bigger box, it means that the line for confidence interval is going to be comparatively small. Okay. So my next study has a total number of participants as only 50. So the box is going to be little small. Okay. And the confidence interval line is going to be larger than the other two. So smaller the box, larger the line. Okay. Larger the box, smaller the line, the confidence interval line. Okay. So this is how I am going to represent my studies. Okay. This is the second one. So now coming to the diamond of the batch. So again, just a refreshment. So first we have drawn a central line, the null line, then the horizontal line. The one side favors the outcome, one side does not favors the outcome, and we know how to represent each and individual study. For example, my study has a population of 50. So I put a 50 box, a random box, and a confidence interval. Now the very important step is you need to understand where to put this box and the line. Okay, are you going to put this over here or are you going to put this over here? Okay, for example, if your treatment is favorable, then this has to be in the favorable side, this side. Okay, if your treatment is not favorable or your intervention is not favorable, you need to put the boxes on this side. Okay, sounds simple, right? But sometime you will see certain things like this. Now, I'm giving you a figure. Okay. I'm giving you a figure. This is favorable side, this is not favorable side, and I'm drawing a box like this. Now, by seeing this, what is your interpretation? Your interpretation is that you have adequate sample size and your confidence interval is also adequate, and your study says that your intervention is not favorable. So this is what your interpretation is as far as this forest plot is concerned. Okay, I'm giving you another forest plot. Look at this. This is favorable, this is not favorable. I have here. So now with this, you will be able to say that my study contains so and so of population with this as confidence interval, and my study is favorable or beneficial. Okay, this is what you need to interpret from this particular diagram. So now I'm giving you a different diagram. Now I'm giving you the third diagram. So this is the first diagram, this is second diagram, and the third diagram. Okay, I have a center line, I have a horizontal line, and this is favorable, this is not favorable, and I have a box here. Okay. Okay. So what is this interpretation meaning? That is, I have a study with this as the population and this as a confidence interval, and it is showing some benefit, your intervention showing some benefit, but your confidence interval is touching the central line. This is what your interpretation should be. Okay. By seeing this forest plot, your interpretation is, I have a study with this as population, with this as confidence interval, and it is showing favorable outcome, but your confidence interval is touching the central line. Your central line is passing through it. Okay, this is what your interpretation is. So what do you actually mean by saying that your central line is passing through your confidence interval? So these and these two lines intersect. So what is that actual inference is? The chance of being null, this is a null line, right? This is a null line. The chance of being null effect is still within your confidence interval range. So this is what it tells you. It means that though there are some minimal intervention, whether it's significant or not significant, in this case it shows significant. Though the study shows some amount of significance, your intervention shows some amount of benefit, still that can very well be by chance itself, because your null line is there within your confidence interval itself. So it is not statically significant. So it can just be a null theorem itself. Okay, so this is what this diagram tells you. I'll give you one more diagram. So concentrate on this. This is favorable, this is not favorable, and you have a box here. Now, so how do you represent this diagram? So here you can say that I have a study with this as my total number of participants, and I have this as the 95% confidence interval, and this study says there is not favorable, your intervention is not favorable, because in this side, right, it is not, your intervention is not favorable, but it is also not going to be statistically significant because your confidence interval intersects with your null line. Your null line is there within your confidence interval. It means that what is the meaning of null line? What is the meaning of null line? The meaning of null line is either favorable nor harmful, right? It's either favoring or it's harmful. So it could be null. So when the null line is within your confidence interval, it means that whatever side your box takes, still this cannot be accounted. Okay, this cannot be accounted. So this is how you need to differentiate each and every forest plot. Okay, so now as a practice, I'm giving you one more. Let us see how you're able to interpret it. Right, ready? So now you have this favorable, not favorable. So this is a study. Now what is your interpretation of this particular forest plot? You are going to say me that there is a good number of participants and the 95% confidence interval is well within the favorable area, okay, and the confidence interval is not touching the null line. So I can say my intervention is favorable, okay, my intervention is favorable, my intervention, this is a final result. Okay, so I'm giving you a second line. So now, how are you going to interpret this forest plot? So here, my study has this number of population and my confidence interval, 95% confidence interval this, and my study clearly says there is clear harmness or there is no benefit in your interpretation. And I'm pretty sure this is the outcome because the confidence interval line is not touching the null line. Okay, so you are definitely sure that this is going to be harmful or there is no benefit. Okay, so I can say it's harmful or no benefit, no benefit. Okay, so now again I'm giving you one more line. So now what is your interpretation? I'm going to say that my study has this amount of population, I mean the study population, and this is my 95% confidence interval, and my study has shown some benefit, but this benefit is not significant. I cannot call it as a benefit because the null line is there on my confidence interval. So this cannot be taken as a benefit. Okay, it's not statistically significant. This cannot be, though it is showing some favorable outcome, it cannot be taken as a benefit because the 95% confidence interval line intersects with your null line. Okay, this is the third understanding. Now coming to the fourth understanding. So what is your interpretation of this figure? You have a study with this as your population and this as your 95% confidence interval, and this intervention has shown harmful or there is no benefit. Though it is showing harmfulness or no benefit, still I cannot take this data or I cannot consider this to be a valid outcome because my null line is just inside your confidence interval. It means that whatever result you are getting could be by just a chance. So that the 1.0 or the 0.0, the null line, that means neither benefit nor harm still lies within your 95% confidence interval. So though it is showing harmfulness or no benefit, this cannot be taken because the null line is well within your confidence interval. This is the next. Okay, I'll give you one more figure. Just try to understand this. Okay, I have two figures for you now. Okay, so here I have 50 as population and this is the confidence interval. Okay, so I have 50 as population and have confidence interval. Okay, and this is the harmfulness. Okay, so these are two different studies. Now how are you going to interpret these two different studies is that study 1, this is study 1, say this is study 2. Okay, so here study 1, so I have this number of population and this is my confidence interval, and this particular study clearly says that my intervention is useful or beneficial, and I am double sure about that because my confidence line is not touching the null line. Okay, now coming to the second study. The second study is almost the same, right? We have this number of population, this as a confidence interval, it has shown benefit, okay, because that at one side, right? It has showed significant benefit. I'm double sure about it because the confidence interval is not touching the null line, right? It's almost the same. But what is the difference between this one and this? What is the difference between this and this? Because understand, this particular diagram is far away from your null line, okay? So this particular diagram, though it is not touching, it's still very close to the null line. What I am trying to say is, as far away it goes from the null line, your data or your result is more significant, okay? As close it goes to the null line, it means that it's almost approaching the null line. That means the chance of getting into the null line is going to be very high, okay? So this is how you need to interpret each and every study, okay? So now we have this figure. Now it should be very easy for you to understand this figure, right? So what does this tells you? What does this tells you? For example, we'll take it as this to be positive, okay? Positive, sorry. This is positive and this is negative, okay? This is favorable, this is unfavorable, okay? So now let us interpret all these things. You have a box, okay? The box looks of pretty size, right? It's not very small, it's a pretty size box. It means that the number of participants in that particular study is good number, okay? And you have the confidence interval also. The horizontal line represents the confidence interval, okay? So it is favoring, the results are actually in the positive side, right? So this study showing favorable outcome, okay? But will you consider that study outcome into your consideration? Answer is no, I will not consider this outcome. Why? Because this confidence interval line extends into the null line, okay? The null line is way within the confidence interval line, right? The central line is way within the confidence interval line. So the outcome of this study cannot be taken because this null line, which tells you that neither significant nor insignificant, that particular point lies within your confidence interval. So the outcome cannot be taken, okay? So now next, there is one more, this first study, there is a second study. There is a second study where the center box is very small. Can you make it out? This is a bigger one, this is a very small one. The center box is very small, it means that it's a very small population, okay? So as I told you, when the box size gets small, the confidence interval line becomes very large, right? So inversely proportional, right? So the box is very small, the confidence interval line is very large, okay? So what does this study tells you? Study 2 tells me that it is conducted in a very small group of population and the study results shows positive outcome, but I will not be able to consider this because the null line is still within the confidence interval of the study. The null line is within the confidence interval of study, so I will not be able to take up this as a significant outcome, okay? Now coming to the third study. So how do you interpret the third study? Look at the box, okay? So this is conducted with a good amount of participants, right? You can even compare to the first box, the second box is small. Compared to the first box, the third box is relatively small, but it's a good number. So you can very well say that compared to the first study, the number of participants in the third study is less. But compared to the second study, the number of participants in third study is more, based upon the size of the box I'm saying, okay? So the third study is conducted with good number of participants and this is the confidence interval, and this study says that my outcome, this study says that my outcome is positive, that my intervention is positive, my outcome is positive, and I can trust this outcome because the confidence interval line is not touching the null line. Can you see that? This is the null line. The confidence interval line is not touching the null line. So I can consider this results, okay? So this is one study which is showing beneficial outcome and you can trust it, okay? So now coming to the fourth study. In fourth study, what is your input? This is conducted with so and so number of participants and is showing a favorable outcome, but the confidence interval line is meeting the null line, okay? So statistically not going to be significant, I am not going to take up this, okay? So next is the fifth study, okay? So here it is conducted with another small number of population and it is showing harmful effects of that particular intervention, but I am not going to take that into consideration because the confidence interval line is meeting the null line, okay? The null line is way within your confidence interval. It means that the chance that your intervention is going to be neither beneficial nor harmful is just a possibility, right? So I am not going to consider this also. So this is how we are going to see 1, 2, 3, 4, 5. We have seen 5 studies on total. Okay, we have seen 5 studies in total. Now we know what is the number of participants, what is the confidence interval, what does it really represent. Is it going to be positive or is it going to be negative? Even it's going to be positive or negative. Should we consider that or not? Everything we are going to see. We have already seen in this one particular picture. Right? Now, what does this diamond represent? Okay. So now there is a question asked. For example, I'm going to ask you a question that can steroids be given in ARDS? Can steroids be given in ARDS? This is a question asked. And you are coming up with 5 different studies, right? So one study is positive, one study is negative, one study is showing some positive but without any clinical significance or statistical significance. Other study is showing some negative, again without any statistical significance. So you have come up with variable evidences, right? So ultimately, what is the take? Ultimately, seeing all the studies, what is the take? That is represented by this diamond figure, okay? So cumulatively, when you see everything, this diamonds will be plotted, okay? So remember, I told you, more the number of patients, less is going to be your confidence interval line, okay? A bigger box has a small confidence interval line. A smaller box has a large confidence interval line. That's what I told you, right? Now, this is called as cumulative diamond box. This is called as this whatever you see here, the dark box, the dark diamond shaped structure is basically cumulative of all the participants in all the 5 studies. Now tell me, if this box contains all the participants in all the studies, will the confidence interval line be smaller or larger? This is the question put to you, okay? So understand, for example, this study has somewhere around 500 people and this study has somewhere 50 people, this study has somewhere 100, this again has some 50, say this also has 50. So for namesake, I'm just putting. So ultimately 5, 6, 7, around 750. So this diamond box represents 750 participants. Okay. So this is the largest of all the boxes, right? When the box is getting larger, it means that the line for confidence interval is going to be the shortest, right? So that is a reason you're not seeing the confidence interval line at all. It's going to be very short. So cumulatively, by seeing this diamond box, what I'll be able to say is, by considering all the studies in this meta-analysis, I'm coming to a conclusion that that particular intervention is positive, okay, and it is statistically significant because the confidence line is not touching the null line. So cumulatively, by analyzing all the studies which is reported here, I'm coming to a conclusion that this particular study is positive or harmful. Then I'm double sure because the confidence interval line is not touching the null line. This is what a proper forest plot representation is. Sometimes you will come across a diamond like this. A diamond can be touching the null line also. So in that case, what will you say? The diamond is switching towards the positive side. It means that by understanding the data of all the studies here, I'm coming to a conclusion that this particular intervention is beneficial, but we cannot consider it because the diamond or the confidence interval is touching the null line. Okay, this is how you need to represent it. So now, you are given a study like this. This was the first slide we have seen, right? So whenever you are given a forest plot, what you need to do, see, first thing you need to see what are the studies. These are individual studies represented by individual authors. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So we are going to club all the 8 studies and we are going to see what the ultimate representation is. So we will get to know exactly whether we need to intervene or not, whether this intervention is beneficial or not based upon this 8 studies. Okay, so the first thing is we need to see what all the studies under which we are going to see, which are all taken into consideration. That's the first one. Okay, the second is the subtotal. Okay, cumulatively come from all the studies, this is a total number of population and this is a total number of controls, and based upon the participant, treatment and controls, we are going to interpret the final result. Okay, we are interested in the final result. Like ultimately, by analyzing all the available studies, ultimately we should come to a conclusion that whether we are going to intervene or not, right? So this is a subtotal. The second thing what you're going to see in a forest plot is the subtotal. Now, there's a concept called as heterogeneity. It's a very, very, very important concept. Heterogeneity. Let us see what is this heterogeneity in little detail. Ideally, if different trials are testing the same outcome, right? A steroid in ARDS, for example, I'm saying you, a steroid in ARDS. If different trials are testing the same outcome, the effect of the intervention should be consistent, right? Why in one study it is showing steroids is not beneficial, whereas in other study it is showing steroid is beneficial. In one study, it's showing steroid is beneficial, but it's not statistically significant. In one more study, it's showing steroid is harmful, but of course, it's not statistically significant. Why? The same intervention is producing different results across different studies, right? So that is a big question. So have you seen multiple studies producing the same results? Multiple studies asking the same question, saying the same results? Unfortunately, it's rarely the case. So many things can affect the results of a trial, such as the researcher bias, the problems in data collection, all these things can matter, okay? So in addition to analyzing the study results, the systemic reviews or meta-analysis are designed to ask one particular question. So whenever you see a meta-analysis of various studies, there will be one question that is being asked. That is, if these studies are all studying the same intervention, why don't they get the same result, right? You need to think about it, right? So each and every study are conducting the same study, but ultimately they are getting different results, right? Why is so like that? So my question is, are the differences caused only by a chance, or is there something else involved? Is there any bias involved in that? If just only by chance, it's okay. But if it's going to be bias involved, we need to be very careful, right? So if it's by chance, then we have nothing to worry about. If the difference are not the result of chance, then we need to be conscious in how we interpret the results. To make it easy to assess the consistency of the paper analyzed, a statistic called I-square is being used. Okay, so what I'm trying to say is, we are conducting 3 different studies. For example, one study is being conducted in Chennai, one study is being conducted in Trichy, one study is being conducted in Vellore. For example, all the 3 studies are being conducted on the same question, that is steroids for ARDS. Now finally, at the end of the study period, we are getting the results, right? What are we expecting is almost 3 studies should result in the same results, right? That's what it is. But they will show some certain differences, at least minimal differences can be present. We are not expecting the same numbers, right? So what we are going to check is how much is the homogeneity, or in other words, how much is the heterogeneity. Okay, if it's heterogeneous, it's totally bizarre, it's totally out of the box. One study from Chennai and the study from Vellore and the study from Trichy are far different, then we cannot consider those things for meta-analysis. But within reasonable extent only they are differing. They are still homogeneous, they are still the same, they are different only by minimal changes, then we can consider them for meta-analysis. This is what it is. So now we need to know how much heterogeneous it is, how much haphazard it is, how much different a study is from one study to the other. This is what we are going to see. That is called as heterogeneity. So whenever you see a forest plot, you will see a small box at the bottom like this. Here there will be heterogeneity will be given. Okay, so this is the heterogeneity, that is 38%. If you see heterogeneity more than 50%, it means that the individual studies which is asking the same question has differed more than 50%. Okay, so how is it even possible? For if you conduct the same type of research, if you are conducting with the same question, but your answers are 50% different, then there's something else wrong, right? So you cannot consider them for your meta-analysis. So the first step when you're seeing a forest plot is go ahead and see this I-square, that is heterogeneity. Okay, how much heterogeneous, how much far apart all these studies are. If your heterogeneity is more than 50%, then those studies cannot be considered for meta-analysis. So this is the first step. If it's less than 50%, if your heterogeneity is less than 50%, then it means that it's more homogeneous. Means those studies are coming up with the same result with minimal changes only. So they can be considered for your final meta-analysis outcome. So as a summary, each horizontal line or a forest plot represented individual study with the result plotted as a box and a 95% confidence interval displayed in a timeline. So you have a box and a timeline. Okay, so smaller the box, the number of participants also less. Bigger the box, the number of participants is more, number 1. Okay, and second, so bigger the box, the shorter is the confidence interval line. Smaller the box, the confidence interval line is also very big. If you can clearly see, when you draw a forest plot, if you conduct a study with a smaller population, it has a very big confidence interval line. So the line is very big means that effectively it can even touch the null point. So this is one reason you need to conduct your study with a good number of population so that your confidence interval line is very small. So the chance of it touching the null point is also less. So this is one reason why you need to conduct a study with a good number of population. So this is point number 1. If the individual study crosses the vertical line, it means that null value lies within the 95% confidence interval. This null value lies within the 95% confidence interval. So this implies the study result, in fact, the null value, and therefore the study did not observe a statistical significant difference between the treatment and control. Okay. So if this line, the confidence line is touching the null line, it means that it is statistically insignificant. So, and finally the diamond, right? The diamond at the bottom of the forest plot shows the result when all the individual studies are combined together and averaged. The horizontal point of the diamond are the limits of the 95. The horizontal point is the limits of the 95% confidence intervals and are subject to the same interpretation as any of the other individual studies. Okay. So if it is touching, it means that it's going to be not significant. If it's not touching, then it's going to be significant. Okay. And which part it lies, whether it is lies in this box or lies in this box also matters. For example, if this is going to be a favorable box, cumulatively your final diamond says that your intervention is positive. If it is in this box, it says that your intervention is negative. Okay. So this representation, whether positive or negative, whether harmful or beneficial, will be represented in the forest plot itself. Okay. When you see the forest plot, at the base it would have been written which favorable, unfavorable, the sites will be mentioned. Okay. So next is the I-square static gives you an idea of the heterogeneity of the studies, that is how consistent they are. If the I-square value is more than 50%, it might mean the studies are inconsistent due to a reason other than chance. This might make the conclusions you draw from the forest plot questionable. Okay. So this is the first slide we saw in our presentation, right? So now this might look very easy for you, right? So can we start with this, right? So this is the first study. What is your first study tells you? It is conducted with a good number of population, right? The box looks good. And we have the 95% confidence interval, say this is positive or this is negative, just for instance. Okay. So this study conducted with a good number of population says that your intervention is positive, but I cannot consider this study because this is statistically insignificant. The 95% confidence interval is touching the null line, so it is statistically not significant. Okay. The step 2, the study 2. What is study 2 tells you? That is conducted with a relatively small group of population, right? The box is small group of population, and the data and the result says that this intervention is negative, harmful, but I will not be able to consider this also because the 95% confidence interval is touching the null line. So this also is statistically insignificant. Okay. Now coming to the third. Okay. This is conducted with even more smaller number of population. The box is even more smaller, and this says that the intervention is positive, but I am not going to consider this also because the null line is being intersected by your 95% confidence interval. So this is also statistically insignificant. Okay. Next, there's one more study conducted with really a large amount of populations. Look at the box, it's a big box, right? A large amount of population, literally 601. See, the treatment arm is 601, the control arm is another 617, it's almost 1200 population, right? So it's connected with a huge number of population, and it shows that there is benefit in that intervention, but it cannot be taken into consideration because the 95% confidence interval lies in the null line itself, is touching the null line. So statistically not significant. The next conducted with a very small number of population, and this shows positive outcome, but it cannot be considered because the 95% confidence interval touches your null area. Okay. So if you see this itself, this study, there's a third study and the fourth study says almost the same results, right? It shows something positive but statistically insignificant. But if you clearly see that the distance between the null line and the study box, this distance tells you how towards it is, right? The more far it goes away, it means that the benefits is going to be more. Okay. If it's very nearer to the null line, it means the benefits going to be less. Okay. So that's next study conducted with a good number of population, and it shows that the intervention is significant, and I know it is significant because the confidence interval is not touching the null line. So this has clearly proved that my intervention is significant. So the next study says conducted with this number of population, it shows significance but is touching the null line, so I am not able to take this into consideration. The next tells you that this is a small number of population, and it tells negative, that is the particular intervention is harmful or no beneficial, but I'm not going to take it into consideration because the confidence interval line is touching your null line. Okay, so ultimately with everything, with all these things put together, I have a diamond here. So this diamond tells me that comparing all the statistics, comparing all the participants and the data, we can say that this particular intervention with this available study is positive. Okay, and I can consider it to be positive because the confidence interval line is not touching the null line. So ultimately, I can go ahead doing that intervention. Okay, so this is this forest plot. So very easily we have clubbed all the 8 studies. We have gone through all the 8 studies, treatment group, control group, and how is the data interpreted, whether it's statistically significant or not. All the 8 studies has been represented in one single picture, that is your forest plot. Okay, and finally, whether to do it or not is also being represented in the forest plot with your help of your diamond. Okay, so now try this. So here, this is the first study which says this is the population group, this is the confidence interval, and it's touching. Okay, so statically not significant. This is also statically not significant. Statically not significant. There are 2 groups, 2 studies which says, and remember these 2 studies are conducted with a big number of population, right? Compared to these 3 boxes, this is a big number of population and they clearly say there is benefit, right? The confidence interval line is not touching. So the diamond clearly is away from your null area, okay? And it clearly says it's positive. So summary measure, I am saying that this particular intervention is positive, beneficial, and to go ahead with this intervention. So now this is your final question and your final interpretation. So this paper published in 1991, that is steroids to mothers whose babies were due to be born prematurely. Okay, so we had lot of studies like Auckland study, Block study, Doran study, Gamsu study, Morrison studies. There were a lot of studies saying please give steroids to mothers who are expecting a premature delivery, right? We do practice it nowadays, right, for the lung maturity of the baby. But though there were a lot of studies, it was not universalized, it was not generalized. Doctors were not willing to accept it, right? So it is because of this particular meta-analysis, it is because of this particular meta-analysis which has clearly stated that the diamond lies in the positive outcome without the confidence interval being touching the null line. Okay, because of this particular forest plot only, doctors started using steroids for premature deliveries. Okay, so that is the significance of a forest plot. Okay, so now can you read this forest plot? Okay, so the first study, the Auckland study, says that it connected with a good number of population and it shows beneficial and is statically significant, right? Now the second one, connected with a very small amount of population, okay, but it shows benefits but clinically not significant. Third study shows benefit, clinical significant. This study, good number of population, shows benefit but clinically not significant, shows benefit, clinically not significant, shows benefit again, clinically not significant. Here there is neither benefit nor harmfulness, right? So these were the evidences at that point of time in 1991. But when you collect the data from all the studies, finally you see the diamond over here. That is, this particular intervention is positive, beneficial, and that particular confidence interval is not touching the null line. Okay, so go ahead and giving steroids for mothers who are expecting premature delivery. This was the final result in 1991. This completely changed the universal treatment protocols in handling premature deliveries, right? Okay, so just remember this forest plot, how it looks. Okay, so this is a symbol of the world famous Cochrane review systems, and in that world famous Cochrane you will be seeing this as a symbol, right? When you see the Cochrane symbol, you will see something inside like a dot, dot, dash, and the horizontal line, right? Vertical lines and a horizontal line. This is nothing but the forest plot. This particular thing is nothing but the forest plot of this particular study which was conducted in 1991, saying the steroids need to be given for mothers expecting a premature delivery. So this forest plot is what you see here inside the Cochrane emblem itself. Okay, thank you so much. So from now onwards, whenever you see a meta-analysis, you're going to see this forest plot. For example, you get a question in your mind whether this particular intervention can be given or not. So this is the question in your mind, and you have various studies. You have a lot of studies. Some studies saying yes, beneficial. Some studies saying there is no benefit, and some studies saying there is benefit but it's not statistically significant. When you come across all these kind of haphazard things, you collect all the studies, put all the data together, you can represent it by a forest plot, and finally the diamond tells you whether to proceed with it or not. Okay, thank you so much.